Hello, everyone. Now, I know we just had lunch about 30 minutes ago, which is about the time when the food coma starts kicking in. So I'm going to try to be as engaging, as captivating, as loud as possible to make sure that I don't lose any of you. But if you want to take a quick nap, make sure you wake up when the talk is done. I'm just kidding. Do not take a nap. I'm going to be talking about some interesting stuff here, namely modern application architectures. And I'm going to be telling you a little bit about Docker containers and containers as a service platform. I should probably grab the remote. So I don't think the slides are just going to move themselves. All right. So first of all, since I doubt any of you have heard about me, I'd like to tell you a little bit about me. I am an engineer at heart, and in my profession, I tinker with things. I tinker with software. I tinker with hardware. I get to run unstable beta software in my production environments. That's because unlike your production environments, if mine goes down, I only get my wife and my parents to call me and complain about it. So nothing happens. It's all good. I first learned about Docker in May of 2013, so about 3 years ago. I watched this video of some Solomon hikes at a PyCon conference demoing this technology, and the title of the presentation was The Future of Linux Containers. Now, I had heard about Linux containers in the past, but not enough to really care or bother about them. But what I found in this presentation, this very short 5-minute video, was very intriguing, enough to want me to go to Google and type in Docker. After a lot of results on pants and men's clothing, I finally found what I was looking for. I was able to download it. And the first successful command that I ran was this Docker run Ubuntu Echo Hola Mundo or Hello World. I like my Hello Worlds in Spanish for some reason. And what happened there just blew my mind. Really, it did. I was able to execute this one command, which in my mind had instantiated what at the time I thought was a VM. I didn't know enough about Linux containers, with its own file system, with its own networking, IP, etc. Executed this one command, grabbed its output, displayed it in my machine, and I had been able to do all of that within just a few milliseconds. Now, that may not be as exciting today, but 3 years ago, that was mind-blowing, to the point where I dropped everything I was doing, and I started building Tutum. Now, the premise for Tutum was very simple. We had this notion of a container, and if you think of the time, back then, as a developer, I had two options available. On one hand, I had a PaaS, Platform as a Service, which I found to be very constraining. I had to adapt my application to run on a PaaS. Or on the other hand, I had infrastructure as a service, which, as a developer, I found to be very complex. I had to manage infrastructure. With this notion of containers, I found the in-between. I say, what if we develop a platform where developers develop in a container? Ultimately, you have everything you need in a container, an operating system. But from the platform perspective, the container is just a black box that I plug in network, I give it some storage, memory, CPU, and let it run. So on that premise, start building Tutum with this notion of a CaaS, a container as a service platform, for 2 years before joining Docker in Q3 of 2015, so about 6-7 months ago. And now I'm the product lead for Docker Cloud. So as I'm sure you're all aware, Docker is leading this containerization movement. Now, Docker is the name for both the successful open source project as well as the company that created the project. As a company, Docker is the maintainer and the main sponsor for the open source. It also provides open infrastructure, public infrastructure for the open source project. So for example, we run what's known as Docker Hub, which is a public registry where these container images are stored on Amazon. If you need another example of successful companies running on top of Amazon. And we have, I think that 1 billion number is outdated. I think we may have hit 2 billion downloads now on that. For the 40% of Docker users that, according to this survey by O'Reilly, are running production environments, Docker also provides technical support through a partnership with IBM. And we also develop additional software to complement our open source offering. That is this container as a service that I'm going to be talking about. So if I had to choose just randomly 3 buzzwords, and remember the title of my talk, Modern Application Architecture, 3 buzzwords to define what this modern application architecture is, I would likely choose something along the lines of DevOps, or automation, microservices, or software-oriented architecture, and cloud. Interestingly enough, Matt actually used all those 3 words sometime throughout his presentation. Now, luckily for me, these are not just buzzwords. There's actually surveys and trends in the industry that indicate this is what people are looking for when building modern applications. And you probably don't disagree with me that software today is the lifeblood of any company. Whether you're looking to develop new and engaging experiences for your customers, or whether you're looking to accelerate or improve maybe internal processes, every company today, regardless of what industry, in some shape, way, or form, is a technology company. And as a technology company, we want to be building modern applications. So throughout my presentation, hopefully you'll find how Docker really finds itself as the centerpiece of this trifecta of buzzwords, not buzzwords. Docker containers are perfectly fit for microservices. Containers run just as well on the public cloud as they do on a legacy data center. And they go hand in hand with DevOps-friendly automated workflows for continuous integration and continuous delivery. And today I'm all about surveys, because we know these surveys offer scientific and questionable data on which to make better decisions. I'm just kidding, but not really. This is real data. So why would you want to build these modern applications? What is it that you'll benefit from a business perspective, right? Sure, as an engineer, as a technologist, this is exciting, but ultimately, how does this translate to the business? And what building modern application architecture enables you to do is to innovate faster at any scale, 5 million, 10 million users, at a lower cost. So both business and the technologies now are going to be happy that you're building modern technology, modern applications. But I haven't yet told you, so what is this containers as a service, right? To put things a little bit in perspective, I'm going to go back to the concept of PaaS and infrastructure as a service, IaaS. So if we were to plot this in a spectrum, and one axis, and we said on the left-hand side here, we've got simplicity. And on the right-hand side, we have flexibility. Then PaaS would be very simple. And IaaS would be very flexible. Now, this one's simple, but it's not flexible. This one is flexible, but it's complex. CaaS is the happy marriage of PaaS and IaaS. If they were to have a happy marriage, CaaS would be born, and you'd find it right in the middle. So CaaS is it's simple. It targets developers, but it also targets operations. Excuse me here for a bit. I have a bit of a cold. I'm a bit of a jet lag, and my mouth is not working here. All right, much better. Let me see if I said everything I had to say about CaaS. All right. So if you stopped by our booth earlier, you probably saw this. What is this? This is an example of a CaaS-enabled software supply chain, of a CaaS-enabled workflow. How would this work? Now, having talked to some of you, I hear that you find yourself with this wall between your development team and your operations team. Well, CaaS sort of destroys that wall and makes it a meeting point. So on the left-hand side, you've got developers developing their applications. They develop their applications with their existing tooling, with their preferred language, with their preferred technology. Once they build it as this application, Docker enables them to easily package it into a container image, which is published into a content registry, a secure content registry, which is the meeting point for your operations and your developers. And then your operation teams picks up these bits from the registry and is able to deploy them without really having to worry about what is running in those containers. They're able to scale them as necessary, redeploy them if something failed, monitor them using existing monitoring solutions, roll back them if there was a bug introduced in that software version, whatever is necessary to make sure that your application is up and running on your infrastructure. And remember, earlier I talked about simplicity and flexibility. This is what my marketing team likes to call the power of and. Simplicity and flexibility. Developers and operations. Of course, you can run this Docker container as a service for your development environment only, for development and staging, for staging and testing. Or maybe you want to do development, staging, and QA. Or maybe you only want it for QA in production. Ultimately, it's your choice where you enable your team to use this CAS platform. On any application architecture, so sure thing today here, we are talking about modern application architectures. But it is often the case, and I'm sure here we've got many examples of monolithic legacy applications that don't live in the cloud. What do I do with those? Do I just turn again my back against them and forget about them? No. We've got many success stories of customers that have been able to grab these legacy monolithic applications and run them on top of the Docker CAS platform. And needless to say, if you've got a modern microservices, automated, cloud-enabled application, those run just as well, if not better. Needless to say, it supports any programming language. If you're familiar with container technology, it'll run just about anything. So you don't have to limit what your developers work with unless you really want to. Any operating system, although that's really come with a little asterisk that says, as long as it's Linux. But the truth is, Windows support is coming, and it's right around the corner. So soon enough, we will not need that little asterisk. And any infrastructure. So sure thing, jump on AWS. It's fantastic, but maybe you can't. You need not to worry. The Docker CAS platform will run just as well on legacy infrastructure that's not virtualized on your data center. And open APIs, plugins, and broad partners ecosystem. What do I mean by this? Because CAS is built using the exact same open API and the same open principles that the Docker open source technology is, you can use the industry plugins and make use of all this large partner ecosystem that we've been able to build over the last 3 years on your CAS. So if you're looking for a specific networking plugin that maybe doesn't come out of the box, that's likely to be available through our partner ecosystem or the open source ecosystem at large. And it's all compatible with the CAS platform. And all of that ultimately translates to choice for you, right? Don't forget the power of and. So agility and portability and control. Now, if you look at Docker, the basic technology, the technology that existed 3 years ago, the reason why it became so popular was because of these two first concepts, agility and portability. What we mean by agility is enabling your team to push software constantly. Every time they change, every time they fix a new feature, they test it, boom, you've got a new copy of your container ready to run, ready to go through your QA process. So you're able to push software faster. The great example that we have with this was ING, a bank out of the Netherlands, I believe. I'm sure you're all familiar with it. It's got a nice big orange and white logo. They went, when adopting Docker, from pushing software releases once every 9 months, which to me seems absurd, but I know that many companies find themselves in this situation, to over 1,500 times a year. Once every 9 months, 1,500 times a year. That's a huge change for the pace of innovation at which you can deliver. Portability, that was the second thing that made Docker what is today. I'm able to run the exact same software in my machine as I am to run in the cloud or a private data center. Now, I'm sure that at some point in your career, all of you have heard this, it runs in my machine excuse from a developer, right? It goes as follows. I'm in my laptop, coding an application, I push it to the source repository. Maybe my QA team grabs it and says, hey, Borja, your application is not working. And I say, you know what? It works in my machine. What do we do? Well, the good thing about Docker is that if it works in your machine, it's going to work in QA, it's going to work in production, and vice versa. So if something broke in production, it's likely that your application had a bug, unless it was the infrastructure that just crapped out on you, in which case, then we got bigger issues to deal with. And lastly is control. When you're given this much choice as to what your developers use, which frameworks, which programming languages, which technologies, and your operations team can also choose how they monitor, how they scale, how they look at the logs of your infrastructure and applications, then you end up with 500,000 different software pieces to do all of this. Docker provides the common piece in all of that. So it enables you to control, with a single technology type, everything from the build, from the beginning of your application development, all the way through your production. So the build, ship, run that we call. That's the common piece between your devs and your operations team. So now you may be asking, okay, this is all great. I want to be building modern applications. I want to be deploying them in the cloud, fully automated. What is CAS? What is this CAS thing you speak of? What do I actually get? Where do I get it? What does it look like? So it begins with Toolbox. Toolbox is a set of tools, like the name indicates, that enable developers to build their Docker applications. Now, Toolbox runs natively on Linux, and as of recent, in Windows and OS X. So regardless of on which platform your developers are developing their applications, they're able to download this Toolbox application, this Toolbox set of tools, and develop their Docker applications. From there, your developers would push this containerized application to a common registry service. The registry service is either available on the public cloud or running on your own data center. And the operations would pick up this containerized image, this snapshot of your application, and run it using a secured, blessed version of the same engine that's been vetted by millions of users around the world. Then there's security. There's security end-to-end. Security is something that we are looking at all the time. Right now, security for Docker means two things. It means provenance. You're able to sign, your QA team takes a look at an image that your developed. They run all the tests through it. It looks good. They sign it. They bless it to run in production. Now, if an application is not blessed to run in production, then if one of your operators grabs it and tries to deploy it in production, it's simply not going to run. If you require your CTO to bless every application that gets shipped to production, unless your CTO signed that application, it's not going to run in production. So that's one of the things that we offer for security. The other one is content trust, content scanning. So if you require your ops to know what's actually in that black box that we speak of, right? Okay, this black box is great, but I actually need to know what's running in there. I need to know if any security vulnerabilities are exposed through these containers. Then the security scans allow you to do that. They enable ops to grab a static image, snapshot of your application, and run it against a set of tests that will identify any vulnerabilities on any of the binary code that's in that application, even post that application running in production. So vulnerabilities are found all the time. Because we have a copy of what's in that container, we're able to say, hey, new vulnerability just came up. These images are vulnerable to that, and ops teams knows about that. So that's security. And then management, which provides a single pane of glass to manage this entire process end-to-end, build, ship, run. And one of the biggest, if not the biggest feature, and there you go, of this CaaS, this container service platform, that is not in this graph, that is not in this diagram here, is this. And what this is that it works, it's so flexible that it works with the software, with the processes that you already have in place. Say, for example, that you use Jenkins, a very popular continuous integration piece of software, right, to run your continuous integrations. You get to continue using Jenkins for your continuous integration. Say that you are running in a legacy, non-virtualized data center. You get to run CaaS on top of your non-virtualized legacy data center. Say you've adopted a fully auto-scaled AWS infrastructure. You're able to run CaaS on top of that infrastructure. And your ops team, I'm sure they've invested a lot of time and sweat in getting some of this technology up and running to be able to monitor your applications, to make sure that they are able to capture logs, to set up networking. They get to continue using their monitoring applications, their logging solutions, and the networks that they set up on top of CaaS. So I think this is the biggest feature that oftentimes Docker fails to highlight, is that it really does work well with just about any technology on any process that you already have in place today. How is it manifested? How is it made available to you? Well, we offer what's called Docker Data Center. That's bits that you can download, run yourself. They offer the end-to-end solution that I described on top of any infrastructure that you have ownership of. And it is also manifested through a SaaS-hosted and managed container service platform that covers the end-to-end build, ship, run process to run your Docker REST application. And this is called Docker Cloud. So I've got a few minutes left, so I think I have time to wrap it up and maybe present a couple of use cases. So just to wrap it up, we started the conversation talking about what is a modern application architecture. And we talked about cloud, microservices, and DevOps. Hopefully in these 22 minutes, even with the food comma, I've been able to convince you how Docker really does enable you to adopt a modern application architecture. But if I have failed to convince you, hopefully I piqued your interest, intrigued you enough to make you want to Google it. Hopefully you don't get as many pants results nowadays as I used to back 3 years ago, to look into it and learn more about what this CaaS platform is all about. We do have some real customers that have had successful stories doing this. What I find most fascinating about the use cases when I learn about them from our team is truly how diverse they are. These customers are doing very, very different things, yet achieving success using this common CaaS platform. So take, for example, ADP. ADP, if you haven't heard about them, is one of the largest payroll service providers in the world. They had 2 monolithic applications, very standard, running on their infrastructure. Now, ADP nowadays runs 2 infrastructures. They run one on their own data center that is powered by OpenStack, and they've run another one in the public cloud on AWS. What ADP wanted out of running this solution was portability. They wanted the ability to move application between their cloud environment and their on-prem environment, and vice versa. And they were able to do that thanks to Docker. They didn't have to reprogram their application when running on OpenStack or AWS. So now they've deployed on that, as you can see, the similar diagram of the workflow that I showed earlier. They have the development team working on their application. They don't have to worry about, is this going to be running on OpenStack? Is this going to be running on AWS? They program the logic of their application. They push that in a common registry, not a barrier between operations and developers, but a common meeting point. And the operators are then able to deploy this on either AWS or OpenStack as they see fit. Another example is GSA. I always forget what GSA stands for. I actually wrote it down. It's a government agency in the US that's in charge of running and making service available for other government agencies. It's called the General Services Administration. There you go. I don't know why that's not on the slide. They were looking to build a platform for their developers. They were looking to also go from monolithic applications and they were able to do both with Docker. So they were able to wrap their monolithic applications, break it down into smaller components, deploy those using Docker, build their own platform for developers to target internally. And they actually did this, and they managed to also achieve, which they were not looking for, reduce time to market, and to improve the security and lower the potential attack surface to just containers of their platform. So I got 5 minutes to spare. Hopefully, those of you taking a nap, it's time to wake up now. Thank you so much for inviting me to be here. It's a pleasure. I hope you enjoy the rest of the afternoon and the rest of the sessions. And have a great day.
Thank you very much. Now, are there any questions? Don't go away. You know, it's not that simple here. Oh, the same person here. I'm so glad. We should give you a present. Thank you so much. Is your question the same for him as it was to
competitor question.
I would like to ask how you scale with Docker to that 10 million users and so on.
How do you scale to Docker? So it's independent of the infrastructure problem. How do you scale with Docker to 10 million users? You follow the same principles that Matt earlier described, except the part that he missed, that automation flow of how you actually get your applications to run on all that infrastructure, you do that using Docker. And then you've got your team happy with the automated flow where the developer does a git push, tests happen, builds take place, things end up in the repository, and the continuous delivery flow where it picks up, hey, new versions have been blessed on the repository, what's running the old stuff, this is running the old stuff, deploy here. Let's just do 20% to be safe. Hey, everything's good. Span, 80%. All right, great. 100% of our population now gets the latest and greatest version of our application. That's very easy to do with Docker. Hopefully that answers your question.
He was nodding.
Good.
Yeah. Any other questions? Let's hit the coffee break. Thank you so much, Borja, for your presentation.
Thank you.